Welcome back to JVM Internals Crashcasts. I'm your host, Sheila, and today we're diving into an exciting topic in our Beyond Expert, Advanced Topics and Future Directions season. We're continuing our exploration of alternative JVM implementations, and our focus today is on GraalVM. Joining me as always is our JVM expert, Victor. Hi, Victor.
Hello, Sheila, and hello to all our listeners. I'm thrilled to discuss GraalVM today. It's a fascinating technology that's been making waves in the Java ecosystem.
Before we dive in, let's start with our traditional quiz question. Listeners, here's a challenge for you. What unique feature of GraalVM allows developers to mix and match different programming languages in a single application? Think about it, and we'll reveal the answer at the end of the episode.
That's an intriguing question, Sheila. It touches on one of GraalVM's most powerful capabilities. I'm excited to see how many of our listeners can guess this one correctly. It's not something you typically find in standard JVM implementations.
Absolutely, Victor. Now let's start with the basics. What exactly is GraalVM?
Great question, Sheila. GraalVM is a high-performance, universal virtual machine developed by Oracle. It's designed to run applications written in a wide array of languages, including Java, JavaScript, Python, Ruby, R, and many others. What makes it special is that it's not just a JVM, it's a polyglot VM that can execute code from multiple languages in a single runtime.
That sounds powerful. So it's like a Swiss Army knife for programming languages?
That's an excellent analogy, Sheila. Just like a Swiss Army knife has different tools for different jobs, GraalVM has different language runtimes integrated into a single platform. This allows developers to use the best language for each part of their application while still maintaining interoperability.
I see. Can you tell us a bit about GraalVM's architecture? How does it differ from a standard JVM?
Certainly. At its core, GraalVM uses a technology called the Graal compiler, which is a just-in-time JIT compiler written in Java. This compiler can be used as a replacement for the standard hotspot JIT compiler in OpenJDK. But GraalVM goes beyond that. It includes additional components like Truffle, a framework for implementing language interpreters, and Native Image, which allows ahead-of-time AOT compilation of Java applications into standalone executables.
That's fascinating. You mentioned AOT compilation with Native Image. Can you elaborate on that? It sounds like it could be a game changer.
Absolutely, Sheila. Native Image is indeed a game changer. It allows you to compile Java applications ahead of time into native executables. These executables start up almost instantly and have a much smaller memory footprint compared to traditional Java applications. This makes Java much more competitive in areas where it traditionally struggled, like serverless computing or command-line tools.
Wow, that's impressive. But I imagine there must be some trade-offs. What are the potential downsides of using Native Image?
You're right to ask about trade-offs, Sheila. While Native Image offers significant benefits in terms of startup time and memory usage, it does come with limitations. For example, it doesn't support all dynamic features of Java, like reflection, unless explicitly configured. It also increases build times and can make debugging more challenging. Developers need to carefully consider these trade-offs when deciding whether to use Native Image.
I see. Now, earlier you mentioned GraalVM's polyglot capabilities. How does this work in practice? Can you give us a real-world example?
Certainly. Imagine you're building a data analysis application. With GraalVM, you could write the main application logic in Java for its robustness, use Python with its rich ecosystem of data science libraries for the actual analysis, and then use JavaScript to create a web-based front-end, all within the same runtime. This interoperability can lead to more efficient development and better performance compared to traditional multi-language setups.
That's a great example, Victor. It reminds me of an interesting anecdote I heard about Twitter's adoption of GraalVM. Apparently, they were able to reduce the memory footprint of their JVM services by 25% just by switching to GraalVM. Do you know of any other notable adoptions?
That's a fantastic real-world example, Sheila. Yes, Twitter's experience is quite impressive. Another notable adoption is by Shopify. They used GraalVM's native image to compile their Ruby on Rails application into a native executable, dramatically reducing startup times and memory usage. This allowed them to better utilize their infrastructure and reduce costs.
These examples really highlight the potential impact of GraalVM. Now, for our listeners who might be considering adopting GraalVM, what would you say are the key things they should keep in mind?
Great question. First, consider your use case carefully. GraalVM shines in scenarios where you need polyglot capabilities, improved performance, or reduced startup times and memory usage. Second, be prepared for a learning curve, especially if you plan to use native image. Third, test thoroughly, as some libraries might not be compatible with all of GraalVM's features out of the box. Lastly, keep an eye on the active GraalVM community for updates, best practices, and solutions to common issues.
Thank you, Victor. Those are valuable points to consider. Now, before we wrap up, let's reveal the answer to our quiz question. The unique feature of GraalVM that allows developers to mix and match different programming languages in a single application is its polyglot capability. This feature enables seamless interoperability between multiple languages within the same runtime.
Excellent summary, Sheila. I hope our listeners found this feature as exciting as we do.
Indeed. To recap, we've learned that GraalVM is a universal virtual machine that offers polyglot capabilities, improved performance through its Graal compiler, and the ability to create native executables with native image. While it comes with some trade-offs, it has the potential to significantly impact how we develop and deploy Java and polyglot applications. In our next episode, we'll be exploring JVM in cloud and containerized environments, starting with JVM in Docker containers. It's sure to be another fascinating discussion. Thank you for tuning in to JVM Internals Crashcasts. If you enjoyed this episode, please subscribe and leave us a rating. Your support helps us continue bringing you in-depth explorations of JVM internals. Until next time, happy coding.